class, and welcome to Parkour Physics 101. This is the correct classroom to be in if you are here for Parkour Physics 101. Yes, my name is Tim, and today we're going to be talking about friction. Yes, today we're going to get into a subject that is very important to parkour. What happens underneath our feet, between our feet, and the obstacles that we're running on, or the ground, or the wall, or maybe even the ceiling. Who knows? There's a lot of friction, and there's a lot of very important things that happen with friction, and it's important that we understand the science behind what is happening underneath our feet. So today, we're going to get into the science of friction. Why does it work? How does it work? What are the nuances of friction? Because there are many. And how can we use friction to our benefit so that we do not fall on our face? Yes, let's get further into today's lesson for the science of friction in Parkour Physics 101. Now for today's lesson in friction, we will be getting into some mathematical concepts and some concepts of physics, but I'm going to try to keep this really simple so that anyone can understand what's happening and the important parts of physics that we should really pay attention to when understanding friction. So stay with me, and you'll learn a little bit of math, a little bit of science, but mostly how not to fall on your face. First of all, what is friction indeed? What is friction? Does anybody know? Questions? No? I can't see any hands? Okay. Friction is that force between any two things that you rub together. Hold on. For instance, we're going to be talking about friction as it relates to this object here. This is a shoe. Our shoe sits on the ground. Slides sometimes. Sticks sometimes. If you have different objects, they will have different amounts of friction. Okay, we're going to talk about this. We're going to do a little experiment later about friction and how much force it takes to slide things on different surfaces. Okay? Essentially, that is friction, and that is what makes us fall or slip or not fall. So, let's not fall. Now, there are different amounts of friction for different combinations of materials. This material, rubber, and I have a binder here. So this is probably like polyethylene plastic on that. And this is a pretty high friction combination. I can still push this shoe pretty easily across it, okay? But it is fairly sticky. It doesn't move too readily. And, you know, if it really depends on how much force you're putting onto the shoe. If someone was standing on this shoe, it wouldn't be very easy for me to just slide that shoe across the surface, right? No, of course not. Let's take this hat, for instance. Fabric hat. That's going to certainly slide a lot easier on this surface. The friction between these two objects is much less than the friction between these two objects. Rubber and plastic, much higher. What we call that is the coefficient of friction. There is a scientific letter for the coefficient of friction, and it looks like this. That is called mu. It is a Greek symbol, and it defines the coefficient of friction. So there's a number that we can put to this combination of materials. We can say that, and I'm just going to guess, we can say that maybe the coefficient of friction here is about 0.4. That's about the number. We can say that the coefficient of friction here is much less. It's about 0.1, we'll say, just for discussion purposes. And there are experiments that we can do to determine what exactly that number mu is. What is that coefficient of friction for these dissimilar materials or similar materials? Some of the materials concerning us in parkour are going to be rubber. Hopefully you're wearing rubber on the bottoms of your feet. Maybe you're wearing sandals. Maybe they're foamy surface, and maybe they are maybe wearing bare feet, right? So skin is an important medium when we're talking parkour friction. Even with our hands, parkour is not only friction is not only happening on our feet, but it's also happening at our hands in a lot of places. So we want to understand the mu, the coefficient of friction between those two combinations of materials: rubber and asphalt, rubber and pavement, rubber and cement, rubber and wood, rubber and metal. Generally, we're going to be looking at those combinations of materials, right? And we want the coefficient of friction of those materials to be as high as possible. Otherwise, whoop, we want the mu to be very high. A high mu, a high coefficient of friction, I would say, is about 0.4 to 0.7 probably. Those are just numbers that we can come up with mathematically through scientific research, through experimentation. We'll take a look at some experimentation in a little bit. But for now, take my word for it. Those are good, that's good friction numbers. Okay, sticky. It's raining outside today though. Guess what, folks? Rain means the coefficient of friction is going down. Slippery when wet. Metal slippery, asphalt slippery. The coefficient of friction is actually going down when things get wet because we have a combination of surfaces that are different now. One of them is wet, isn't it? If your shoes in the gym are wet, the coefficient of friction is going to go down in the same manner. If you come in off the street and walk through a puddle and your shoes are wet, then please wipe them off. For goodness sake, wipe them off. But if they are wet, the reason it will be slippery is because there's still water in between those surfaces and that coefficient of friction will be lower. Yeah. Okay, class, come in a little closer. Let's now talk about why mu is so important and what it means to us in parkour. The important part for you is to realize whether or not your shoe sticks or slips, right? That's really the most important part. Does it stick and stay put, or does it slip? This formula here will tell us that. It will tell us that F equals mu times N. Very important formula, okay? What does this all mean? F here. This is the friction force. This F is the force it takes to overcome the friction imparted by the two surfaces, okay? Mu here, this is the coefficient of friction. This is what we can determine scientifically about the two surfaces. As you recall, I had my handy dandy binder and my shoe here, and I called this, I think I called this about 0.4 coefficient of friction, didn't I? So we can stick that into our equation here. Now, what is N? N is very important too. N is going to come into play when you're jumping onto something because N is the normal force. What is normal force? What? N is the amount of force that you exert on the ground or on the object in the direction of, perpendicular to the friction. In this situation, I'll line it up with the board here. Whoop. The shoe is coming down onto the surface. There is some amount of normal force because of the weight of this shoe, but more importantly, the weight of your body and the movement, the momentum of your body coming down onto that surface is pressing very hard directly downward onto the surface. This is called normal force. N, right there, pressing down. It's an amount of force. It's a number that is quantified by pounds of force or newtons or other units of force downward. Okay, and F over here is also a unit of force, but it is in the direction of the surface of which we are applying force and of which the friction is in question. Okay, that's confusing. There's an arrow here. We have normal force going down, and we have friction force in line with the surface. Got that? F equals mu N. I know this is all very boring. I know this is math and science and physics, but you know, when you start to understand what's happening at a very microscopic level under your feet, it becomes a lot more fun and a lot more engaging when you're doing parkour, that you can think about these things and think about, I know that the coefficient of friction between these two objects is a little bit greater. I know that I need to exert a certain amount of normal force on this object such that I do not slip and fall on my bum. Now let's make this a little bit more exciting, shall we? I have the resemblance of a man or a woman jumping and landing on a surface. Now this surface resembles the ground, or a rail, or a block, or any other object that is fixed in space and stationary. As you remember, we have a certain coefficient of friction between any two materials. Material 1, his shoe or her shoe. Material 2, the ground, whatever it is, okay? Let's assign a number to that. Let's say that we are jumping with our sneaker onto a relatively sticky surface, and that coefficient of friction, mu, is equal to 0.4. Sound good? We have also this arrow drawn underneath him. Now this is, or her, underneath her. This arrow represents the amount of force exerted into the ground going directly down into the ground, or into the object. This is, as you recall, represented by the letter N, normal force. Now, the normal force is going to be multiplied by the coefficient of friction in order to determine a very important number, which, if you recall from our equation, which I have erased, but I will put back here, F equals mu N. And when two letters are beside each other, we're going to multiply them together. So N is going to be a number based on the weight of the person and the height from which they've jumped and the amount of force that they use to absorb with their legs the fall onto the ground, the landing. So for argument's sake, for simplicity, we are going to say that N is equal to 100 pounds of force. 100 pounds. Maybe you're a small person, you're a child, and you're jumping down onto something, and you're landing with some momentum, and you're probably exerting roughly 100 or more pounds force into the ground, directly downward. However, when you're landing, you can see that this person is jumping from somewhere over here. Whee! They've jumped. Woo! Now, when they land, they are not going to land with all of their force directly down into the ground, are they? If you jump straight up in the air and straight back down, then all or most of your force will be going directly into the ground. However, if you're jumping from a distance or doing a precision, you will be jumping from a different place. To get from place 1 to place 2 means that you are traveling in a direction, which means that to stop yourself, you need to also exert force in a certain direction to stop yourself. This is going to be the friction force, and we will draw it here as exerted by the shoe onto the ground, and that is F. So not only are you exerting force into the ground, you are also exerting force against the surface of the object or the ground on which you are landing. This is the frictional force, and this is very important. Now, I'm going to get the red marker out. We're going to look at this equation, and we're going to put these numbers into it. 100 pounds, normal force, into the ground. And we're going to look at this number here, mu, 0.4, coefficient of friction between rubber and asphalt, or metal, or plastic, or a number of things. Those two numbers we're going to multiply together in our formula here to get, what do we get when we multiply 100 times 0.4? We get 40 pounds of force. And that, my friends, 40 pounds is the maximum amount of force that we can exert onto that object in this direction. If we are sliding, if we are pushing our feet in that direction, if we're jumping too far or running too fast, then a lot of that force will be the frictional force. We may not exceed 40 pounds force in this particular scenario. Presumably your numbers will be much higher if you're a grown person, or if you're moving at a high rate of speed, or if you're falling, jumping down from a greater height. All of these numbers will be increased. But it's important to note that this formula will always be in question, and you will always be able to determine how much slippage you will have or will not have. Now, class, let's talk about a very important subject: static versus dynamic friction. When it comes to movement and jumping onto things, it is important to understand that there's a difference between static friction and dynamic friction. What does that mean? Static friction means the two objects are squished together and trying to slide against each other, but they cannot move. There's a certain coefficient of friction at play when two things are not moving. Dynamic friction means that things are sliding. And there's a certain coefficient of friction that happens when two objects are sliding. Now, this is a great experiment that we can do together, you and me, with just our hands, okay? Static friction, put your hands together and push them together just slightly so that there's a little bit of force, and this is going to be called our normal force. We're pushing our hands together. Now try to slide them without moving them. Push one way, and then the other way, and then the other way. And that's static friction. Now that's pretty sticky. Our skin, depending on the moisture in our skin and how much we're pressing with our normal force, of course. Now we're going to slide our hands. Keep pressure on your hands and continue to slide them until they slip. Aha! Aha! The slipping is what we are calling dynamic friction. Yes, indeed. Static friction occurs when two things are fixed, when we stuck a precision, or we've landed on it, we've stuck to it, and hopefully we maintain static friction throughout the landing. However, that does not always happen. Once our feet start to slip, the dynamic friction between those same two materials is actually much lower than the static friction. So once we have slipped, you can feel it with your hands, you have a good amount of friction here, but as soon as they start to slip, they really keep going. That's dynamic friction. So if, for example, the static friction between two objects is 0.4, the coefficient of friction, those same two objects, those same two materials may have a dynamic friction of 0.3 or 0.2 or something much less that allows them to, once they've started sliding, to continue to slide, which is very unfortunate for parkour practitioners such as yourself. Static versus dynamic. Yes, very important. Slip, fall, bang, ow. Now, class, I very much appreciate you being with me here today on this little friction journey and exploring the physics of parkour movements. The moral of the story here is do not slip and fall on your face. Boom. Do not slip and fall on your back. Ouch. Okay? Understanding friction can help us overcome these types of incidents wherein the normal force between our head and the ground will be greater than what would be acceptable by our physical body and what could be absorbed by our nose and our cheeks and our glasses and whatnot. So please do be careful when training parkour, especially when it's raining like it is today. I hope that this has been helpful to you all. I have had a blast here with you, and I hope that you join us next time for Parkour 101, the next session, if there is one.